Hi guys, this is the second problem that we are gonna solve in our DSA series. So yeah, let's get into it. This is the problem. Given two strings S and T, return true if two strings are anagrams of each other, otherwise return false. Now what's an anagram? An anagram is a string that contains the exact same characters as another string, but the order of the characters can be different. For example, take this RACECAR. All these characters are present in here, but the order is different, right? I think you got clarity what an anagram is. Now let's get started and write in function to see if two strings are anagram of each other or not. Function is valid anagram. Now this is a simple solution. We can simply do mm, now first let's have S and T here as an input. Both are strings. S dot split, let's split this, then let's sort it, and then let's join it. Right now, if this is equals to T dot split dot sort dot join, that means it's an anagram. Oh, and one more thing, we'll split it, like where to split it from, no? So yeah, between each character we got to split it, and for join as well we later got to join each of the characters. Okay, so it will return true if both strings are anagrams of each other, else it will return false. Now let's see time complexity of this. Split has time complexity of n, or we can write O of n. Let's simply write n for now. Okay, this sort has time complexity of n log n. This split has time complexity of n because we have, like, it has to see in between each character if like this exists or not. So yeah, sort has time complexity of n log n. Again, similar to split, join has time complexity of n, and since we are doing it here as well, let's repeat them, and then again log n, then n. And since we are comparing each and every character, this comparison will have time complexity of n. So the total time complexity will be the largest one. Since we are not multiplying them, total time complexity is n log n. So yeah, here the time complexity is n log n. Now there is a better way to do this. Is valid anagram. Again, let's take S and T. What I'm thinking is, let's say there is this anagram Rajat, which is my name, and another one like TAZAI. Okay. Yeah. So I'm thinking of making two objects. One will track this, one will track this, and then at last we'll compare them. So what I'm saying is, the object will store the frequency. For example, it will have the key R, and the value will be 1 because R came 1 in this is came once in this string. Then for A it will store 2, for J it will store 1, for T it will store 1, and similar for this. Then we'll compare those two. Let's say R, okay, R here came 1 and here also came once. We'll compare these two objects, right? Once the first object will be made from this string, the second object will be made from this string. Again, we'll compare A. Okay, A came twice. J, okay, J here came once, but in this object there is no J, so yeah, it's not an anagram. So this is what I'm thinking. So let's implement it. Const. So before doing that, actually, what we can do, we can say s dot length is equals to t dot length. This is O of one operation. If length, okay, if these are not equal, then we can simply return false, then it's not in anagram, right? I think you can understand it. If length is not equal, obviously the characters are not exactly the same in both the strings, right? So yeah, we can simply return false here. But if this is in the case, then we can have const, we can have two objects. One we can call like count, since we are storing count, how many times an object is being repeated. Then we have const count 2. Okay, now we can just loop over for let letter of s. Let's loop over this s string, and we can check if count 1 contains this s key. So the value, so if in count 1 this s exists, value can be anything, can be like 2, 3 or whatever, but if this is s exists, then simply do whatever the value is there, simply increment that by 1, right? If it doesn't exist, however, if it doesn't exist, then simply make it 1, the value 1. That means it has been encountered for the first time, or the very first time, and for the if it's been encountered the next time, the value will be incremented by 1, so the next value will be 2 and 3 and so on, right? So yeah, so this is how we'll fill the values in count 1 with all the frequencies of characters coming in the string s. Now let's do the same for this, for t. Oh, not s actually, sorry, not s actually. Here the letter will come. Yeah, s is a string, right? We'll go for individual letters. Letter. Yep, letter. Now let's see here. Let's just copy paste this. Again, we'll do this for t. For t, we'll again see, instead of count 1, we'll fill count 2 with the frequency of characters present in the string t. Okay. So this will give us count 2 and count 1. Now finally we can compare count 1 and count 2. So what we can do is, we can simply have a for loop, let letter of object dot keys, let's say count 1. We will simply do if count 1 letter is equals to count 2 letter. That means if, then do something. So that means, let's say there are this is, let's say, object 1, there is count 1, d1, right? So it will check, let's say this is an object and again this is an object, right? If a came once, d came for 1, if it doesn't match, let's say d here is 1 for d here we came 1 and for second object d is 5, then it will be false, and we know it's not an anagram, right? Or if there is some letter that it exists in this but doesn't exist in this, then again it's not an anagram, right? So yeah, if this is equal, then so instead of equality we'll say if it's not equal, then simply return false. It's not an anagram. However, if this loop is completed, that means we have not returned anything. That means it's an anagram. We have checked all the keys of the object. So let's return. It means it's an anagram. Now let's again see the time complexity of this. Here time complexity is O of n, since we are iterating. This is n, and this is again n. So yeah, n plus n plus n. The time complexity is O of n, because we are not doing any nesting, right? So it is O of n. However, it can be made little better. Time complexity cannot be, but yeah, the code can be little more optimized, right? So what we can do, instead of having one object, we can have a single object. We can simply have a single object. Let's have this as well, is valid anagram. Let's keep this as well, is valid anagram, let's say 1. Okay, let's is valid anagram 2. So let's valid anagram final. So let's optimize the above one. So instead of having one object, let's have two objects. Let's have only one object count. We can, instead of having two for loops, we can simply have a single for loop for let I equals to 0, I is smaller than s dot length, because we know s and t have similar lengths from here, right? And then we'll do I plus plus. Now what we can do here is okay, we can say this count object si, right? We will check this value, like for this, we'll check if O, like count with key R exists, count with key A exists, and things like that. So we'll check, okay, if count if key is there, then simply do count with key plus 1. And the problem with this is there might be the case if it doesn't exist. If like it's undefined, then we can't add one. If it's undefined, simply have 0, right? Yeah, if it's undefined, have 0. If it's not, then simply add 1. And again, what we can do here is we can take count t. So what I'm doing is here simply subtract 1. You got my point? So we'll have a single object with all the values as 0. If that is the case, then it's an anagram, right? For example, if let's say a came twice here, then here a should be subtracted 2 times. So the value of a should be 0, and this should happen for each and every character, right? So the values in the whole object should be 0. All the values should be 0. That means it's an anagram. If it's not the case, then it's not an anagram. So yeah, so we will do this, and then we can simply map over the object. Let letter of object is okay. and then we can see, since count 1 doesn't exist, only this count exists, we can say if count letter is not equals to 0, that means it's not an anagram, return false. However, if we went through this whole loop and still haven't found anything other than 0, that means it's an anagram, return true. So yeah, this is our final version. And again, it has a time complexity of O of n and space complexity of not O of n, but instead O of 1. Why O of 1? Because it says SNT consists of lowercase English letters only, and there are constant number of lowercase English letters. It is 26, right? There can't be any more. So the space complexity of it will be 1. Space complexity 1. I'm gonna push this code. Is valid anagram, yeah. So yeah, this is the final version. Let me write here final. Okay. I'll give you the link in the comments. If you want, you can directly see that. Valid anagram. Yep, that's it. But thanks for watching, guys. That's all from my side.